Alright, so in this video, we want to go over some thermodynamics practice questions coming from this tutorial sheet. We've got questions 1 up to 5. So just a basic energy profile diagram, and then look at the first law of thermodynamics. On question 2, question 3, we'll look at the calculations that involves heat. Okay, and then 4, we'll look at calculations of enthalpy of the enthalpy using the enthalpies of formation, and do the same for 5, the enthalpy of the reaction when we're given the other reactions. So that is S's law. And then lastly, we'll look at question 6, where we go over the use of bond enthalpies in calculations of the enthalpy of the reaction. Okay, so let's start. Question 1, nitrogen gas reacts with the hydrogen gas to form ammonia gas, and 91.87 kilojoules of energy is released to the surroundings during this reaction. A says write the balanced chemical equation for the reaction. Placing the energy on the correct side of the equation, draw an energy profile diagram for the reaction indicating the reactants, activation energy, enthalpy change. According to your answer in B, the potential energy greater for the products or less than to the potential energy of the reactants? Give a reason for your answer. So we'll start over from question 1. Okay, so we have the reaction between nitrogen gas, and then nitrogen gas is reacting with hydrogen gas. They both exist atomically, so to form ammonia gas. So ammonia gas is NH3 to start with. Okay, all these are gases. You can add the states: gaseous gases, gases. Okay, now is the equation balanced? No, it's not. We have to balance. How do we balance? We've got 3 there for the hydrogen, so we can add the 3. That would now require us to put a 2 there so that we can balance the hydrogens. Okay, so that's now balanced. Now A is saying not only are we writing the balanced chemical equation, we should also indicate the energy, place it on the correct side of the equation. So what are we told in the question? We are told to say that amount of energy was released. So is this endothermic or exothermic? So it's an exothermic reaction. Okay, so there are 2 ways of presenting based on the way the question is asked. If we had it, it should appear when it's exothermic, it means energy is being produced, right? So which would make it a product. So we can add it on the right side of the equation, plus 91.8 kilojoules. This is more like a product. Okay, now there are other ways that we can actually indicate, as you would see from this question. If I put it at the end like that, it's different. In this case, I'm not adding it as either a reactant or a product, but the sign indicates whether it's exothermic or endothermic. The negatives are exo. So we've answered question 1, A. Question 2, question B, we have to draw the energy profile diagram for the reaction, correctly indicating the reactants and products, activation energy, and enthalpy change. So this is an exothermic reaction. Okay, so I'll remove this just so that we can have enough space. So energy diagrams, usually energy profile diagrams, are in 2 types. There's one which is like this, and then there's one like this. So one thing that you need to understand is this indicates the reactants, this indicates the products. So this is where, of course, on the right you're talking about the energy. Okay, so this implies this is reduction in energy, which is exothermic. This is endothermic, increase in energy. Okay, that's simple to understand, that's simple to see. Okay, so in this reaction, what kind of reaction do we have? Do we have an endothermic or exothermic reaction? So the reaction we have is exo, implying that the energy of the reactant is going to be higher than that of what? The product. Okay, so we'll start somewhere up like that. So this is now where we've got our reactants. What do we have as reactants? We've got nitrogen reacting with what? So we've got nitrogen reacting with our hydrogen. Okay, you can write it as it is balanced, indicate the states as well. I will not indicate the states, but you should indicate the states. These are our reactants. Now, for reaction to actually progress, there's need of what we call activation energy. Okay, there's need for what we call the activation energy. So that's now where you see the energy going up. This is going to be something like this. Okay, it usually makes sense if it's round. Okay, so this is an exothermic reaction, so it has to come down lower than the products, or rather than the reactants, so that we have our ammonia gas there. Okay, so I have to indicate that which one is our activation energy. Our activation energy is this part. So while you are seeing that is the activation energy. Okay, now the difference between the energy of the reactants and the products, this difference, this is now what we call the enthalpy. Okay, delta H. So the question said we should indicate the reactants, the products, the activation energy, and the enthalpy change. Okay, so I've indicated for us now. Okay, so I hope you can see the activation energy. Actually, the activation energy makes it's supposed to be something like this. Let me put it properly. From that point to this point, you look at the energy of the products, the reactants, sorry, up to what is required for the reaction to progress. That's activation energy. Now the energy difference between the reactants and the products is the enthalpy. Okay, I hope that makes sense. Now we can move. C says, according to your answer in B, is the potential energy of the products greater than, less than, or equal to? What do you think? So if you try to look at your reactants compared to product, you see that since on the left, this is where we have energy on the y-axis, that's a level of energy. Okay, this is called the energy profile diagram. This shows the progress of the reaction. Okay, so basically then you know what we're talking about. Okay, so that has got higher energy than this. So the reason is very simple. Potential energy of the products is less than that of the reactants because they were losing energy. The reactants were losing energy. Okay, so they are the greater energy because compared to the product. I hope that makes sense.